Hello friends, welcome back to this lecture. This is the lecture number 17 in this series. In this lecture, we are going to discuss about the cracking in beam due to flexure shear. As in previous lecture, we have seen the two types of cracks in the region 1 and the region 2 due to the flexure and due to the shear separately. Now, in this lecture, we are going to discuss about the cracks which are going to form in the region 3. So let us start the discussion over it. So as we have seen previously also that whenever the beam is subjected to external loads, the bending moment variation and the variation in the shear force results into the development of cracks in the different parts of the beam. And as we have discussed previously, that in the region 1, the main predominant uh, as in the region 1, the bending moment will be the predominant. So that's why the bending stresses will be the predominant, which causes the vertical cracks in the region 1. Then in region 2, the shear force is predominant because at the zone 2, the shear force will be maximum and the bending moment will be minimum. So that's why the shear force will be predominant. And as a result of this, that we have seen the main cause for the cracking is the shear stresses. And due to these shear stresses, the cracks are going to form the diagonal due to the diagonal action along the 45 degrees as we have seen previously. Now we are going to discuss about the crack formation in the region 3. So in this type 3 region, as you can clearly observe that this type 3 region will be found in the quarter span of the beam. And as we can see clearly, as shown in here with the red strip, in this quarter span, the bending moment is still considerable, and at the same time, the shear force is also significant. So, bending moment is also significant, and the shear force is also significant. So, the whatever cracks which are going to form in this region, these cracks or this cracking pattern will be the combination of type 1 and type 2 cracks we have seen previously last lecture. So these cracks emerge at the tension faces in vertical direction due to the flexure and gradually tend to bend in the diagonal direction toward the neutral axis as the shear stress goes on in. So the nature of this crack will be just like this, as you can see in the figure, that these cracks will start from the flexural portion or the extreme tension fiber, and this crack starts in vertical direction, and you can easily found here that this crack is almost vertical, then it's bent in the inclined plane, and as you move toward the support, the crack starts in vertical plane, but then it moves in the inclined plane or it bends along the diagonal due to the predominant shear stresses, and it may reaches up to the neutral axis. So this is the crack pattern which we normally observe in zone 3 or in type 3 region, and the main reason is the mixed action of the shear stresses as well as the bending stress, because the bending and the shear stresses are predominant, or you can say that the both type of stresses are having almost equal predominant action in this region. Since these cracks develop under the combination of shear and the flexure, that's why these types of cracks are referred as flexure shear cracks. Types of cracks are referred as flexure shear crack because, as you can see clearly here, that this initially this crack is propagating in vertical direction due to the bending action, and then it bends in along a 45-degree plane due to the shear action. Okay, so that's why this kind of cracks are also referred as flexure shear. Okay, so this is about the cracks in all three types of regions, that is type 1, type 2 and type 3. Let us again summarize these cracks. And cracking in the beam will occur in the three regions. In first region or type 1 region, as we have seen, that the mainly the predominant uh, parameter which is resulting the cracks is the bending stress, and due to this bending stress the cracks will form in vertical direction, as you can see clearly here. Then in region 2, the main predominant parameter is the shear stress, and due to these shear stresses in zone 2 or the region 2, the diagonal tension will get developed, which results in the formation of diagonal cracks. Then, as we have discussed just while an ago, that in the region 3 or type 3 region, the main reason for the crack formation is the mixed action of bending as well as shear. So these cracks will form in the shown manner, that is vertical in initial nature, and then it tends to the inclined plane is along the principal plane due to the shear. So this is about the cracking in the beam. As we have already discussed that the exact analysis of shear in the RC beam is a little bit complex phenomena, and to understand that exact analysis or exact behavior of the RC beam in shear, several experiments have been conducted, and after conduction of these all experiments, it has been understood that there will be various modes of failure which occur due to the shear or due to the combination of shear and bending moment. And these modes of failures can be discussed in detail. So we'll discuss these modes of failure in detail further part of the lectures. For now, we'll stop here. Thank you. If you like this video, don't forget to click on the like button. And if you are not subscribed to this channel, so don't forget to subscribe to this channel. And again, after subscribing, don't forget to click on the bell icon, because after clicking on the bell icon, you will get the notifications of videos uploaded in future.